Thanks, Neville, and thanks for inviting me back a couple of years later. So I hope you remember a little bit of the last time I was here, some of you, and you can see what we've built on since then. I can't actually recall if I was still at the Shoalhaven Marine and Freshwater Centre when I spoke last time, but at the Shoalhaven campus out here. But since then, as Neville said, I've moved on and started a company because I felt that you can stand in the ivory tower of academia and tell the world how it should be done, but you should probably also get out there and do it and lead the way. And so that's what I'm doing now. That's why I've started the company Venus Shell Systems. And I'll explain a little bit about what we're doing within Venus Shell Systems through the production of seafood that's potentially very good for our health, but also a number of the clinical studies and medical applications that we're looking at from some very unique molecules that we're able to grow in some of the seaweeds that we're doing. As Neville said, I'm still an honorary fellow at the University of Wollongong. Venus Shell Systems is my main company now, but FICO Health is the second company that you might see more often because that's our consumer-facing brand. We've developed products now that are on the market, and FICO Health and phycology is the study of algae and seaweeds. And so FICO Health is seaweeds and algae for human health. I'm also part of the Blue Biotech Shoalhaven network, which is a network of local businesses that have enabled us to go from growing seaweed to processing the seaweed and putting it into finished products like bottles of cosmetic creams, for example. So we can get those made with neurochemicals because they're now part of the Blue Biotech Shoalhaven, looking at what can we do with this new product we're growing here and work with existing businesses and industries to value add to their manufacturing capacity as well. Hopefully the region can become known as a bit of a blue economy biotech hub. That's the vision. I also have an office at the iAccelerate Centre at the University of Wollongong's Innovation Campus. But why seaweed? I'll just go back and touch on why seaweed again, because it's one of the fastest growing crops. In fact, it's about 20 times more productive than any other land crop. So we farm, for example, out here in Nowra, Bomaderry. We capture carbon dioxide from the large distilleries there at the Manilta Group, and we also capture and remediate nutrients that are washed down when they wash out all of their big containers and boilers there. We capture those nutrients that are digested, and we pump those into big swimming pools and grow seaweed. As I said, 20 times faster than any land crop. So if you grew wheat on a hectare, you might expect to get a yield of about five tonnes in a year on a hectare. We'd get about 100 tonnes in a year on a hectare, dried seaweed. It's also about 40% protein. So we actually grow more protein than a cattle farm. It's all got all the essential amino acids. I bet none of you ever thought about seaweed as your next protein source. But it is one of the fastest growing crops. And we don't use fresh water. We use salt water, so we don't have droughts either. So from a sustainability and efficiency point of view, seaweed just makes a lot of sense. As I mentioned, we're actually capturing carbon and bringing that down back into the biosphere faster because we capture directly off fermentation and industrial processes. Straight off the fermenters here, about 350 tonnes of carbon dioxide is released a day just through natural fermentation. And because it's food grade carbon dioxide from fermenting yeast, we can just capture that and put it straight into our CO2 line and production of seaweed. It's also a $10 billion now global crop. Seaweed's a $10 billion global crop, and no one in Australia is really growing it except us. So we've really missed the boat on a crop for a continent that's girt by sea. And it's an unexploited resource in the West. It's not only us. Western nations throughout the world and Europe have not embraced seaweed as a key crop. But now they're starting to do it. Norway's investing a lot of its oil money into seaweed research. Italy, Spain, the Western world is now gaining a lot of speed in the production of different seaweeds. And they're doing it for many different products. So seaweeds are actually, you've touched molecules from seaweed today. If it wasn't the paint on the wall here, which has seaweed in it, it might have been in your toothpaste this morning, or it was in the ice cream you had for dessert last night. It's even used in printer inks, so the ink on the paper holds seaweed molecules. Fire hydrants have seaweed extract molecules in them. And that's how seaweed's currently mostly used in the West, unless you have sushi on the odd occasion. But throughout Asia, the primary use is food. And that's what we're trying to change here, is use it for food, but also there's a whole opportunity of marine medical products that we could develop from it. So it's not a here's seaweed, you can do one thing with it. It's a here's seaweed biomass, we can do so many things with it. So it's a very versatile crop. And its nutritional potency, some of the key missing nutrients in our diet in the West, and a cause for many of the chronic lifelong disorders that we're facing today, are a result of diet and some critical components that are missing, primarily omega-3s, a range of trace elements, but very importantly, and what we're doing clinical studies on, are the very complex glycans or fibres, dietary fibres. And we're only getting about half of the amount of dietary fibres that we need today, and that's now recognised as being a cause of many chronic inflammatory disorders, about 70 of them, from everything from diabetes to lupus to rheumatoid arthritis to psoriasis, multiple sclerosis. They're now not being treated by a dermatologist if you've got psoriasis or a neurologist if you've got multiple sclerosis. They're now being treated by people who understand the immune system that is triggered from the gut. And we're also developing a range of biomedical materials that we're printing new human tissue with, healing wounds and that sort of thing. And above all, the customer is now open to this. Maybe 20 years ago it would have been even harder to convince people to embrace seaweed as a new crop and product. But today, people pretty much get that seaweed's good for you. Now we just have to educate on why and how we can use it. This is a graph showing the rise of the seaweed farming industry. So seaweed farming, even though they've eaten it in Asia for thousands of years, there's records 2,000 years BC of the importance of seaweed to people in China for the preventing iodine deficiency. But it was only farmed for the first time in the 1940s after an English scientist discovered how nori, the seaweed that you might have seen wrapped around sushi, how it reproduces. The sex life of seaweed is very complicated in different species. And so she unlocked the process for the nori seaweed, and the Japanese now have a day in celebration of this scientist. Her name's Kathleen Drew Baker. And once a year in Japan, they have the Kathleen Drew Baker Day for unlocking the nori farming industry for them. And now you can imagine those nori sheets are available in narrow fare, sushi rolls, Coles, Aldi. You can get those everywhere. But the only reason for that was because she unlocked the reproductive cycle and how to cultivate and farm this seaweed. And again, that's 1940s. It's not that long ago. It's not even a century ago since that farming technology was developed. And since then, you can see, this is from the 1970s, how the red seaweeds, which is the red line, have just accelerated. So the last decade, that's actually a different red seaweed in Indonesia and the Philippines. And now that seaweed farming in those countries employs many people and is now sending many young children in those developing countries to schools. They have seaweed villages, and those seaweeds are the kind of seaweeds that you would find in your toothpaste, your ice cream, and the wall on the wall paint. You can see there a jagged brown line. That's actually the rise of the brown seaweeds, and the key country farming brown seaweeds is China. And I'll say that China is actually fueled by seaweed. Without seaweed, China would have massive iodine deficiency and massive brain damage. They wouldn't be able to think and develop at the rate they had. They've recognised iodine deficiency so long ago as one of the critical problems for growth in their country, and established seaweed farms in the 1970s just to get iodine. Iodine is recognised by the World Health Organization and the deficiency of iodine as the biggest cause of brain damage and the easiest type of brain damage to eliminate from human world health at the moment, just by taking some iodine. It's illegal to sell salt in China that is not iodized. In Australia, maybe only 10% of people buy iodized salt. How many of you here buy iodized salt? Maybe a bit more than 10% here, but iodized salt is essential for brain health and hormonal function. Then also you can see on the bottom line a green track. Green seaweed really hasn't been exploited and developed much at all, and that's what we're targeting and focusing on, is the green seaweed. So it's a great opportunity for Australia, and we're growing a very unique Australian endemic species. Just to illustrate how big seaweed is in the world, look at this map, this chart here on the left. You can see the green bar. That shows how much seaweed is farmed in the world every year. If you look at the bars on the right, that is how much fish and mollusks. The first bar is mollusks. The grey bar is mollusks. That's oysters, mussels. That's how much of those are grown in the world every year. Seaweed far outstrips the production of mussels and oysters. Then the two blue bars are marine fish. Aquaculture of fish is now bigger than wild fishing. So you imagine how many fish are produced in the world every year through aquaculture. Those are the blue bars. But that's how much seaweed is farmed every year. It's a massive crop, and Australia has just simply missed the boat on this. So since 2009 and at the University of Wollongong, I did start to write a series of reports on how does Australia embrace this missed opportunity. Which species should we look at? What markets should we look at? I didn't think that growing sushi and competing with Japan and Korea and China now was a very smart thing to do. So we should look at what are the unique species of seaweeds, because Australia, just like we have unique land animals and plants, kangaroos, koalas, gum trees, we have very unique seaweeds in our oceans, different to the Northern Hemisphere, different to nori, different to kombu, different to wakame. So we should embrace our diversity in the oceans and look for new species. Which markets should we target? We wrote about the global status and our unique opportunities and positions, and we then started to talk and network across Australia who wants to be part of a new seaweed industry. Then we selected species to work with and started doing cultivation trials, looking at the reproductive life cycle of the seaweeds. How do you grow them? They don't have seeds, they don't plant them like plants. How do you grow them? And then also best practice, because as I just mentioned, iodine is really important to our health, and seaweed is a key source of iodine. But you only need trace amounts of iodine. I said we're deficient in it, but we only need 1 teaspoon our whole life. We just need it all the time, throughout life. And we weren't deficient in iodine back in the days when we used to have milk bottles, if you recall, and they were washed with iodine and then returned, and we returned them to the milkman, and he came back with the washed bottles full of milk again. Because they washed them with iodine, we used to get iodine from the milk bottles. And as soon as they took away the milk bottles and we went to paper carton milk bottles, Australia fell into chronic iodine deficiency, and we're still there today. But we can't overdose the iodine because you only need a teaspoon your whole life. So it's very important to have good practice standards and know which seaweeds to eat, how to eat them, in what foods, in what doses. Because already one Australian company has overdosed a type of seaweed with too much iodine and made people sick by overdosing the iodine. To grow our seaweed, we've moved into the quarters of the Manilda group down the road here in Bolong. And you can see on this image here, we capture carbon dioxide, nitrates, phosphates, magnesium, just natural, because they're processing wheat. They're really an extension of farming processes and farm nutrients. So we're just recovering the washed down nutrients that come out of the processing there at the Manilda wheat refinery. And from that we could grow, just from their waste streams, we could have a 3-hectare farm in Bomaderry producing 300 tonnes of dried seaweed a year, or 3,000 tonnes of dried seaweed a year, just on 3 hectares, capturing the carbon dioxide, the nutrients, adding seawater and sun. That's it. And then we've got a 300-tonne high-value biomass coming out of Bomaderry. And with that, we're starting to develop a range of food products, skin products, and different medical products as well. This just outlines how we're vertically integrated all the way from capturing the sunlight and the CO2 through the controlled different types of seaweeds we grow. That's an overview of the farm that we've currently got. That's a pilot farm next to the ethanol distillery there. And we have a little extraction plant now in the old paper mill. So we outgrew the facilities at the university and left the university and built a small factory in the old paper mill. We're now one of the only people in there, a bit spooky and old for any of you that have worked worked in there and know what it's like. But it's exciting to be inside a facility that was employing 900 people in the region and now doesn't, and we only employ 5. We've got a long way to go. But because seaweed is a big industry, it can go far, and it can be a new industry for the region. So we do a range of extract from our seaweed. Here you can see pouring out of there the honey-like liquid is a special polysaccharide that we've been doing clinical research on for gut health and reducing immune system problems. We can also extract pigments, trace elements, and omega-3s from the seaweed. So what do they contribute to in terms of health? Well, vitamins. Seaweeds have got B12. So there's not many plants on land that have vitamin B12. And so many vegetarians are deficient in B12. So one thing you don't get if you're not eating meat. But B12, vitamin C, vitamin D is very important, as you know, bone health. And we also have a number of trace elements that protect some of those vitamins. I'll jump to those trace elements like boron. So boron is a very important trace element. We're catching that from the ocean. So these are ocean trace elements. You can imagine that on the soils, all of the trace elements are actually being washed out and leached out as we keep using and overusing the soils in our agriculture. And you know in your gardens how you have to keep supplementing with trace elements and nutrients to top up what's being taken out. But the oceans don't run out of trace elements. Those trace elements are always there. And so we're able to deliver high concentrations of trace elements in our products. Pigments like lutein. Lutein's taken now as a very important pigment to protect macular degeneration at the back of the eye. We have a lot of pigments like that, so eating the seaweed can prevent those types of diseases. And we also, as I said, the glycofiber or the polysaccharides that we pull out for gut health, and I'll speak a little bit more about that shortly. Omega-3s, we've run some clinical studies here in the local prison where we showed that aggression and impulsive behaviour was significantly correlated to the blood level of omega-3 in prisoners. That was an ABC Catalyst a few years ago, and we published that work, and now that study's been awarded $2 million to go to 5 prisons throughout New South Wales and take it to the next level to show if we can supplement prisoners with omega-3 through capsules, because they don't get a lot of seafood in prison, maybe we can make a difference to the impulsive and aggressive behaviour that they might otherwise exhibit in a prison system, and take on some of the educational opportunities better, because omega-3 is essential for a proper brain function and cognitive health. Iron, of course, every country in the world is still deficient in iron except Chile, and iodine, as I just mentioned. And this graph here, just to show you some bars on the iodine stories and why you need to know your seaweeds. And that's what's important about the work that we're doing in terms of best practice for seaweeds, is that they are different to land plants. So you can't be a chef and take seaweed as if it's a cucumber and chop it up and make a salad with it in any quantities, because you wouldn't do that with land plants or mushrooms, for example, that you didn't know. Seaweeds are generally pretty safe, but you do need to understand them to start using them in food production. So this is just a map showing you the iodine content in about 10 grams of different seaweed species. And you can see the red line there represents the safe level of iodine in your daily intake. And on the far left, the one below the red line, that's the green seaweed we work on. The second bar, that's very tall, is kombu. And kombu is eaten very regularly throughout Japan, but in a broth, and so you're not eating large amounts of kombu. Whereas a company in Australia overdosed kombu into soy milk, thinking that it's just safe, and they had so much iodine in it that it made some people very sick for about 5 years. And this is just a map explaining why we need to understand seaweeds better and have a best practice standard set in Australia in collaboration with the government on how food manufacturers should use seaweed in foods or not use seaweeds in foods in too large quantities. And it's also the reason why we can use our green seaweed at a high level in foods, because we don't have too much iodine. We have iodine, you can get your iodine from our seaweed, but we put about 10% seaweed into the green pasta that you see there on the screen. And you're still well within your daily safe limits, and you also get your iodine, but you also then get other trace elements, because you can eat more of it. You get On top of 71% of your iodine requirements, you'll get 33% of your magnesium, 65% of your boron, which is important for bone health and protecting vitamin D stores, 42% of manganese, and 40% of your iron. In fact, there was a study in India with a green seaweed fortified chocolate and anemic teenage girls. So 20% of maternal deaths in India are caused by iron deficiency or anemia. It's a chronic issue, health issue worldwide. And just by eating the seaweed fortified chocolate, they eliminated it. Very simple. So we also then did some clinical studies with our seaweed extracts looking at the gut health, because we knew that the West is chronically deficient in dietary fibres, and especially different types and the sulfated types of dietary fibres. So we did a clinical study here in Nowra a couple of years ago, and we followed it up with one in the Wollongong campus at the Illawarra Health and Medical Research Institute last year. And the first study, we looked at reversing pre-diabetes and cholesterol, and we did that. We reduced cholesterol, we reduced inflammation by taking the seaweed fibre supplements for 6 weeks. And we measured the whole gut flora, all the microbacteria in our guts, and we shifted that to a better ecology of gut flora. Things like bifidobacteria increased. But interestingly, after that study, a couple of people who had some pretty bad psoriasis disorders, and this woman was suffering badly from the palms of her hands were peeling off, literally. So she was walking around with bandaged hands and lost her job, lost her partner over this. And that was for a whole 2 years prior to the trial. She was living with that. And we were not focused on this at all. But during the trial, she took these photos herself. Her hands cleared up. She took her bandages off. And it was a proper double-blind placebo-controlled study, so we didn't know what she was taking until the end. And in the end, we found out, yes, she was taking the 4 grams of seaweed fibre a week. And when she stopped the trial, a few weeks later, you can see the peeling of her hands came back. So we put her on and off this a few times, going, yeah, it seems to be clearing up. And then we started to look at why would that be? And then we found out that more and more inflammatory diseases like psoriasis are not going to be cured from the outside and with dermatologists, but they can be cured from the inside and what you're putting into your gut. Your gut is 35 square meters of surface area of you, and you're exposing it to the environment every day with everything that you're putting in there and past there. 35 square meters is a lot, and it also represents 70% of your immune system. So you're actually hitting your immune system 70% every day with what you eat. And if we're not eating the right things, then our immune system is going to play up on us. And that's what we're starting to recognize now, is that many of our disorders, like psoriasis, our immune system is gone out of whack. And you can treat these, preferably not through drugs, but through changing dietary practice. But it's very hard. If everyone in Australia suddenly wanted to eat the right food tomorrow, it is logistically impossible, because our food system is set up in such a way that it is cornflakes for breakfast, white bread for lunch, and refined foods for dinner. And if that's how we're eating all our lives, that's what the food chain is being developed to support, then it's very hard to change that at a large scale. This is why we're looking to seaweed, because we can inject with these foods that we eat every day. Spaghetti bolognese, for example, is the main food that's eaten every day of the week in Australia. So why don't we just put seaweed into the pasta? 10% seaweed in the pasta will give you back trace elements, give you back dietary fibres, and give you back omega-3. So we don't have to change our food practices too hard, and the pasta actually tastes quite good. I'll show you some after the talk. Yep.
On the POM from way back.
I just put a POM up on the screen for you.
And from a child, I'm 86 now, from a child I was always told that we had to have iodine to prevent goiters.
Yes, yes. So goiter is part of your thyroid and your hormone function. So it's important, one, for hormone function, the thyroid, and preventing goiter, as well as your mental health. And that this study was written up about in Michael Mosley's Clever Guts diet book, which some of you might have seen around the quarters. And so but he didn't tell us he was going to write about our clinical studies in that book. And so that surprised us in about about a year ago. And so the last year we've been trying to keep up demand of these capsules from the clinical study, and we're getting some of those out now. But the need is great. Many people contacting us for help on their gut health issues. I won't go into it in too much detail, but what is it we're extracting from the seaweed when we do this? If you look at seaweed in the ocean like this, why is it looking so clean and healthy all the time, when if you put anything else in the ocean, it might look like the guy at the bottom, full of barnacles? If you've seen the Pirates of the Caribbean, that's what you end up looking like normally if you just get put in the ocean. But seaweed persists like this. Why? Because this is a picture of the cells in that seaweed, and you can see that between the cells is this gel-like connective tissue, or the slime of the seaweeds, as you might know it. And it isn't just simple slime. It's full of molecules that defend the seaweed against viruses, bacteria, other species. It regulates the salinity and the osmotic stress that the seaweed has to go through in the oceans. And that gel or slime is a glue of life and sticking the cells together, but it also connects and helps it communicate. We're now learning that around each of our cells, we're glued together. If we didn't have glue gluing our cells together, we'd be just falling apart as a bunch of cells. Our glue now we're learning, is vital to the communication in our own systems, and this glue between the seaweed cells is what we're pulling out. And what's exciting about the particular green seaweed we're working with is that the glue in this seaweed is nearly exactly the same as the glue between our own skin cells. It's different to the brown and the red seaweeds. And this has meant we're able to start looking at wound healing and printing tissues. And so we're doing research with that at the University of Wollongong. You can see here there's 3 critical groups of seaweeds. Red seaweeds, which a nori comes from, even though it might look a bit brown sometimes. Brown seaweeds, which are your kelps. And the green seaweeds, which we work with. You don't have to remember the stuff on the left, but it just illustrates the different types of molecules that are distinctly different between those different categories of seaweeds. And at the bottom, those molecules are just like the human connective tissue. So we've done a lot of genetic barcoding, finding which species resemble the human tissue the most, and the one that resembles it the most is the one we're growing here in Bomaderry Nowra. You can see on the left here, the bright green are images of fluorescing human cells. So these cells have been grown on a 3D printed scaffold, or like a lattice or a sponge that we've printed with 3D machines of our seaweed extract. And then we put skin cells and collagen from the skin cells and watch how it grows over this scaffold. And we can actually grow new tissue from it. There's not many things you can see the cells are attaching, they're anchoring to this scaffold and growing on it. If you took an alginate from another seaweed, that wouldn't happen. They just sit there at balls. They don't recognise the substrate. But our human cells recognise this, and that's why we've also started to put it into just wound healing skincare products. We're not making clinical medical claims at this stage on the skincare range, but we just wanted to get it out there because we can put it into skincare. And so this range of products is actually being launched next week, 5,000 units of those. And this is a picture of some of the printing work that we're looking at the University of Wollongong, because in India many people are born, for example, without the outer ear has been deformed. And so printing a new ear, for example, with human tissue on it, could help the lives of many people in developing nations like India, where small ears are part of their health challenges that they face. So this is a range of some of the products we make from our seaweeds. I've brought some here just for you to have a look at if you'd like to. We've got we do a muesli now, so you can have your seaweed for breakfast. These are some of our corn chips. I could open that and people can have a taste. Okay? I'll try and open that one. Corn chips are eaten very regularly, and so this is simple corn, canola oil and seaweed, 5%. And that way kids can get a healthy snack at lunchtime. This is some of the spiral pasta that we make, just to cook pasta like bolognese, as you might every night, many nights of the week. This is like a dukkha blend. Many of you have heard of dukkha. You dip bread in olive oil and then in a herb mix. So that's a very popular blend that Australians like now. We got a gold medal for that blend at the National Food Awards in Melbourne. And we do macadamias roasted in our seaweed. And what else have we got? These are some of our capsules that I was talking about from the clinical study. And these are like a muesli bar snack bite. The entertainment centre stocks some of our products, and Flavours Shoalhaven in Berry stocks some of our products, and we're going to look at getting into some of the other supermarkets as well. We're sold online as well. We sell online, and you might have seen some of the books around town that we've done. And this is Michael Mosley's Clever Guts Diet book that you can also buy online that you're in. This is a book I did in 2014, and I got 27 seaweeds from around the world, 18 chefs from Sydney to Melbourne, and we feature the chefs in here, but most of them come from the Shoalhaven. So there's Cupid's and some of the Milton Aldullah and Wharf Road restaurant here are in this book, and I told the chefs, cook anything with the seaweed but not sushi, just to show that you can put seaweed in food every day. And indeed, our heritage in Old Ireland, if you like, and in Scandinavia, where I'm from, we used to eat seaweed. Lava bread, you might have heard of, is seaweed and lard mixed together. It sounds delightful, but that was a common food. And so we did used to eat seaweed. You don't have to eat lots of it, but if you get 5 to 10 grams of seaweed a day, you can address so many of the chronic disease deficiencies that we face through a life of not complete diets. So this is where we're at, and the target that we have for our seaweed production here. But don't forget that there are opportunities in paint, fire hydrants, printer ink. Seaweed actually stops the herbs and spices from sinking to the bottom of the salad dressing bottles in the supermarket. That's all because of seaweed. Margaret Thatcher was a chemist before she was a politician, and she prevented crystals forming in ice cream by putting seaweed extracts into it. And even solar panels and things now are starting to use some of the molecular components of seaweed. So don't forget seaweed. It's going to be part of our life every day. It is now and into the future. But our focus here in Nowra is to have farms to make products for global health and sustainability issues, as well as a future of biotech materials and medical devices that we're exploring at the university. So thank you. Any questions?
What are the dominant, I have two questions.
Yes.
What are the dominant inhibitions on business growth?
One, it's hard to convince people, traditionally has been to convince people that seaweed is something that's going to return them lots of profits in the future on investment. So investment has been a challenge, but also finding the right kind of investors. But recently we were contacted by an international, now my microphone's gone, yeah, an international...
Sorry.
The question was what were the barriers to scaling the business, and that is just, investment pretty much, but the right kind of investors. We're now looking at a group coming from California and Spain who are large aquaculture people, and they understand what we're on about. Hard to find people that understand us in Australia that are in the investment space. And your second question here?
There is a lot of plastic junk floating around the oceans at the moment that will inevitably disintegrate. Is there any vulnerability on the part of the seaweed farming to the disintegration?
Seaweed can't be contaminated. It's usually the poorer marine animals and birds that suffer from the seaweed and taking it in and things that filter. Seaweed only absorbs molecules like nitrogen, ammonia, nitrates, phosphates. You don't want to grow seaweed in areas where there's heavy metals. You wouldn't farm seaweed in Sydney because it can capture things like copper, cadmium and things like that. And you need to grow it in a clean area, which is why our lovely catchments on the south coast are very good for seaweed farming.
What's your
Yeah.
Lee?
Yes?
I can remember before the Second World War as a boy seeing French farmers in Brittany in the Bay of Biscay loading horse and carts with seaweed.
Yes.
But they would spread it on the field.
Yes, yes.
And recently I saw another program on SBS regarding farmers in the Hebrides or somewhere in Scotland doing exactly the same thing. But now it appears to have advanced to a great deal.
Well,
and that's 50, 60 years ago.
Yeah, and it's still very important in agriculture, and it should be more important because, one, it can replenish those trace elements that have gone missing, but also the slime is important for the, if you like, the gut health of the soil. The bacteria in the soil actually improve from the same molecules that our gut bacteria improve from. And so seaweed in agriculture is becoming big again. It's a very ancient practice, but it's very important. So even large-scale agricultural places are now looking at we have sea salt for the garden and other brands, and people know that. And a number of people tell me they go down to the beach. You can collect 20 kilos a day for personal use and put that into your compost or onto your plants, and it's very beneficial. Yeah.
What's your email address?
It's phycohealth.com. So PHYCO health.com. I've got some brochures here if you want to. I can. It's all right. We can pass some brochures around if you like.
Arnold.
Pia, thank you for a most interesting and informative presentation.
Thank you.
One of your
slides
mentioned an anti-inflammatory effect. Is that correct?
Yes, yes.
Is that correct? A number of us here would be on blood thinners of one sort or another for various reasons, and therefore unable or shouldn't take anti-inflammatory products. Does the anti-inflammatory effect of the seaweed have the same potential downside as does the other?
No, it's not, because it's not a drug. It's a food supplement, and so it works in a different way to anti-inflammatory drugs. So anti-inflammatory drugs are there to block metabolic process, and they'll go straight to that point and block a process that would normally happen. What we're doing here is looking at shifting gut flora, potentially the inflammatory processes in the body as well, are from what's called leaky gut syndrome, which you might have heard about. And if you've got the wrong kind of diet, your body actually lets inflammatory molecules pass from your gut into your bloodstream. And so leaky gut is one mechanism for inflammation to enter the body, and it's one of the reasons that some people have chronic inflammation. It's not the only process, but, for example, if seaweed then shifts gut flora, improves the mucus lining, and prevents things crossing the barrier, that's one way in how it can reduce inflammation. And so it's not a drug, it's not interfering with other drugs, and it's a very different process. So it's not an anti-inflammatory drug, but it can naturally help to reduce inflammatory processes in our body.
With
a massive yield of seaweed, how much sunlight do you need? Is it below the surface, or where exactly is the seaweed catchment?
Yeah, we're the only limiting factor in our production because we can feed it everything else it needs, all the nutrients, all the CO2 it wants. The only limiting factor for us is sunlight. And so we do have a dip in winter when the sunlight hours go down and come up again now in the spring and summer. But our pools are only about 60 centimetres deep, and the seaweed's always tumbling and coming up to the light regularly. So we can't grow it deep because seaweed needs light.
Mike.
Have you done any studies on the effect of arthritis?
Yeah, so some of the joint health issues are inflammatory issues, and indeed some joint health issues like psoriatic arthritis are linked to psoriasis. So probably about 70% of psoriasis sufferers have as well a joint type of psoriasis, whether they're aware of it or not. And so that type of psoriasis, if the seaweed has the kind of shifts in your gut and your immune system that help psoriasis, then hopefully that will help joint health as well. And these molecules are similar to things. They're in the same kind of category of things like they talk about with glucosamine, you would have heard of. These molecules are similar in structure to that. Yeah.
That's a quick one. I was in the Antarctic and there's lots of seaweed down there. And in fact it clogs up propellers and things like this.
Yeah.
Is it a different type?
Yes, so the question was the Antarctic has a lot of seaweeds and are there different types? And yes, just like the Australian seaweeds are different to the rest of the world, Antarctic will have its own. And like on land, you don't grow bananas in Tasmania and you don't grow blueberries in Townsville. And that's because the climate zones, the temperature and nutrients are very different. And so different regions have very different seaweeds. And they're more different than land plants. Yeah.
Alan.
Yeah, two things interested me. First of all, your work in the prisons with regard to behaviour. Has any thought been given to contacting the Northern Territory government to see if they can modify the behaviour of the wild young kids that have in prison up there? And secondly, your skin scaffold. Is there any thought been given or any scope of repairing burns victims?
Yeah, so to your first point on the prisons, we actually have approached and they're potentially working with Tasmania and South Australia and their prisons. Northern Territory hasn't been approached, but if this information then and the second study is successful again, we envisage that prisons will be recommended to roll out omega-3 supplementation as part of their care for prisoners. And you can imagine that this population is probably a population, or we've actually measured that in the blood. This population is even lower in omega-3 than the average Australian because this population has often grown up in a less advantageous environment, demographic, not great education and not great food. And so their omega-3 levels are even lower at the start. And so they're at a disadvantage from the beginning by not having omega-3 in the diet. And it's a shame to think that, just what they eat could be part of the cause, not the only cause, but part of the reason for aggressive behaviour. Yeah. The second question, what was it again?
The skin scaffold.
Skin scaffold, yeah.
For burns victims.
Yes, yeah, definitely. No, so wound healing and burns is something we're definitely looking at. So our next work will be to go into clinical studies. We're also looking at treating diseases of the cells in the mouth. So you might have heard of mucositis, which is what people who go through cancer therapy can get. The epithelium of their mouth and throat is worn away. Not just the hair goes, but the skin on the surface of their mouths and throat go, and they can't eat and end up in hospital, not because of the cancer, but because they can't eat. And it's very painful. And so we're looking at some therapies where we might be able to spray and coat the linings of mouths again to heal and soothe that during that period.
John.
Featured on ABC this weekend.
Was it? Okay.
Did you want a question?
Oh, the question I had was, you mentioned tumbling in the creation process. Is that a very big element of expense, the production costs?
Yeah, so production costs are, we grow pretty intensively, so we need seawater pumps coming in because we're growing on land and things. But because we're growing it so fast, those costs are producing a lot higher yield. Tumbling, we tumble the seaweed, it doesn't sit, so it's quite efficient to grow. It just tumbles in the seawater and we don't grow it stuck to anything. And that means we can, my mission is that I'm going to lie in bed with my smartphone harvesting seaweed by turning pumps on and off. That will be the day. Not quite there yet, but the systems and the efficiency of the seaweed production is part why we're building the pilot here, to make that all work really well.
Margaret?
A few years ago, we were all being told that the latest wonder product that we all should be using because of our lack of omega-3s was fish oil. Recently, I've heard a number of different people saying that the fish oil that we now buy isn't what it was packed up to be in the first place. Do you have any opinion about that? And is your product, is it capsulized like fish oil is as well?
So the issue is not whether fish oil and omega-3 is good for our health. And in fact, you don't need to take supplements at all, not ours or omega-3, if you eat fish 4 days a week. Do you eat fish 4 days a week? No. So you would need to take omega-3 supplementation because you need that level of fish too, unless you're eating very oily fish like anchovies or mullet, and some salmon as well can be very oily, and you may only need fish twice a week then. But if you're not getting fish 4 times a week, you're not getting enough omega-3. And the average Australian is not. The average omega-3 intake blood level is well below what's recommended by the World Health Organization. And so omega-3 supplementation is required. What the issue is around omega-3 supplements is companies cheating and not putting in the good stuff, not putting in the right concentration, and not having the critical omega-3s that are called EPA and DHA. These are the very long-chain omega-3s that you get in the salmon and the other fish. And fish are the most efficient way to get omega-3s. The creator of omega-3 is seaweed and algae. Our seaweed makes omega-3 molecules from sun and water and nutrients. Fish don't make it. They accumulate it from the seaweed in the food chain into their own system, just like we do. So we can't make omega-3s either. We have to eat it. And we're not getting enough of these long marine ones. And so therefore, the solution is looking for a reputable source of omega-3s, a company that we hope we can trust, and hope that they have a good production source and preservative management of the omega-3 so that when we do take it, it's effective. But we used commercial omega-3s capsules in the prison study from fish in that study, and that shifted the omega-3 profile of the prisoners. So omega-3 supplements from a reputable manufacturer are good.
And how do we work that out?
That's the hard thing. It's the regulatory bodies that we need to put our trust in. I'd say companies that we're all familiar with, the big ones like Nature's Way, Blackmore's, those companies, they're going to lose out by it, and they'll have their eyes on them. So if they don't put proper omega-3 and dosage into their capsules, then it would cost them greatly. So I would imagine that they have a very good omega-3 quality. We've fortified ours because seaweeds don't have a high concentration of it. They're not very oily and fatty. We've actually fortified with a different algae that is quite oily. So with our seaweed gut fibre product, we brought in an omega-3 from an algae from the USA that's very rich in the DHA that's important for brain health. So we have that in our supplements as well, but we've added algae from another producer that focuses on omega-3.
Mike?
With your fish, is it the processed fish that's reliable as a fresh?
If you use frozen fish is quite good because they usually freeze them immediately. So fresh fish is great, but if it's sort of fresh after a week, like it just hasn't been frozen, then your fats start to break down and things. So fresh fish or frozen fish is great. The more processed the fish is, if you're buying frozen packaged like casseroles or fish fingers or something, probably a lot of that's been worn out by the time it gets finished and also removed. So some of the important parts of the fish and omega-3s are actually just under the skin. But if they're just taking out the middle bit of flesh and you're not getting just what's under the skin and the fattier bits of the fish, then you're not getting it. Whereas if you get salmon, and you can buy salmon now pretty cost effectively, and you get the skin on it as well, fry that to a crispy contact condition and then eat the skin, and you'll get a lot of omega-3 that way, as well as collagen from the skin, which is very good for you as well.
John.
Yes, salmon, tinned tinned tuna has some omega-3 in it, and we did see that some of the prisoners actually bulk up on tuna deckhands in the prisons, and that helps with some omega-3, but you need to eat quite a lot of it because tuna is not very oily. But sardines does the best. If you can eat sardines on once a week, you don't need to eat omega-3 capsules. Yeah.
John?
On the trade name, FICO,
yes.
Is that what we're going to see on the shelves?
Yes, FICO Health.
Is that going to minimise my commercial risk?
Your commercial risk
as in the quality.
The quality. Oh, right, that quality. Yes, so if we've got omega-3, we definitely have omega-3 in our capsules, yeah.
Brenda?
If you were to be taking the gut health, you wouldn't need to add omega-3.
So omega-3 and the dietary fibres are different things. So they work in different ways. So the chronic deficiencies in the Western diet are not just one. There's there's 3 categories of chronic deficiency in the Western diet where seaweed can help. And one is omega-3. And we can help in that way in that we do have omega-3 in our seaweed, and you do get some good omega-3 from our pasta and things, but it's not really fatty and oily, so concentrating it is hard. If you feed our seaweed to abalone and to fish, though, they get more omega-3 from our seaweed. They concentrate it for you, and so we've actually got aquafeed development happening to get omega-3 back into the seafood. We turned abalone back into seafood in a study because they were eating pellets in an abalone farm made from wheat, corn and chicken, no omega-3 in that, and so the abalone didn't have omega-3. So we fed them seaweed and we turned them back into seafood because they can concentrate that up. So the omega-3 is different. That's a fat, it's a lipid. The gut health dietary fibres are carbohydrates, very long chain carbohydrates. They're different. And both of them are important in inflammatory processes, but in different ways. So there's lipids, omega-3, there's dietary fibres, and then third category is all the trace elements that I was talking about, like iodine, iron, all of those things you need in small amounts, but they're very critical to our health. Those things can come from seaweed as well.
Well, what if your doctor didn't want you to take fish oil because it seems to be already on blood thinners? And
oh, yeah, okay.
Thins it even more.
Yeah.
Would taking the other thing, would that be?
Yeah, the dietary fibre won't thin your blood. Fish oil does thin your blood. Yeah, it does. Like Eskimos, if they get cut, they bleed badly because they eat walrus. They eat fat from seals and things, and that fat is full of omega-3. So you can actually get quite thin blood from eating a lot of omega-3. It's not unhealthy. It's fine unless you're cutting yourself and then you're bleeding a lot. Yeah. Yeah.
Any other questions? Looks as if you. Yes, Warren.
Thanks for that. It's been really interesting. One of the things that I was thinking about is to scale this thing up. So you've got a source of waste supply coming from the factory, but there's not that many factories like that around. How important is that waste stream to the whole process that you're putting together?
It's just ideal here now. It's the no-brainer opportunity is that we have a nutrient, a CO2, a salt water, and a sun source all in the one spot. It's like serendipity. Wow, that just all happened here in Nowra while I was looking for somewhere to do it. So that was just lucky. But I have built other seaweed farms elsewhere, and my background is in linking seaweed production to aquaculture of fish and other species. So if you have a fish farm, for example, the fish breathe out carbon dioxide into the water. They defecate and put nutrients, ammonia and those sorts of things into the water. And so you can latch on a seaweed production farm onto a fish production farm and capture nutrients from that. And wherever there's a nutrient source, either distilleries, piggeries and manure, if you can anaerobically digest that and turn it back into trace elements, you can start to use that. But I can run it from buying nutrients and CO2 as well. But it's a no-brainer to do it here in Bomaderry.
Any other questions? No, I think you've just about exhausted the...
Did you like the corn chips?
Yes. There's a few left.
Thank you very much, Doctor, for that talk. It's certainly an eye-opener and, as you say, a no-brainer for this area too. And we're just lucky to have your expertise in this area. And I guess as an ex-wheat farmer, I'm totally in awe of your production per hectare. That's something that can only be dreamt about. But thank you very much, and I'd just like to give you... Oh, yeah, we're in the press.
Yes.
Thanks, brother. Thank you very much.
Thank you.